One. Uh, Short bio on me. I never turned a bio in either. I apologize to everybody. But I've worked at UDOT for 16, 17 years now. Worked in design, maintenance, construction, and project management over that time. We're also joined by Jason Simmons. And it says Jason is a Region 2 pavement engineer, where he oversees the region pavement management program and performs all pavement designs in the region. He is a licensed engineer in Utah and has a bachelor's and a master's degree in civil engineering from the University of Utah. John Ogden, sitting here next to me, John's a civil engineer with civil engineering degree from Utah State University. He has 6 years at the Idaho Transportation Department. He has worked in construction, design, traffic and safety, and 9 years in UDOT materials and construction. Kirby Woodard sitting next to him. Kirby does Trans-Tech 3 at the Parley Shed 234. He enjoys anything outdoors and being with his family. Okay, with that, I'll go ahead and start. CTAB, cement treated asphalt base. With the cement treated asphalt base, it's a new process. I'm going to let Jason spend a lot of his time talking about the design and how he put together the design for this project. But it's different than traditional cement treated bases in that we've stuck with just 100% wrap. Typically we've used varying degrees of added soil to help stabilize the base, but this is the first experience in Utah that we know of where we've used 100% wrap as the base. Okay, project overview. I'm going to talk a little bit about the project and about some of the challenges we had and location and other things that we encountered on the project. The project was on I-80 between Silver Creek and Wanship, and that is located just east of Park City, for those who aren't familiar with the area. It's 7.5 miles. It's a 2-lane divided highway. Started off, it was an asphalt. The project was chosen to be constructed because we were experiencing some significant failure in the asphalt surface. There was some of the cords that we'd taken, and I'll let Jason go into further of this too, but showed significant raveling and in the layers. Okay, scope of the project was it was a 2-year project, kind of $36 million budget. It wasn't, like I said before, it was an existing asphalt surface that was starting to experience significant failure. In total, we're going to be put down approximately 380,000 square yards of the CTAB. And on top of the CTAB, we put a 12-inch layer lift of PCCP. The project also had significant drainage where we did edge drains in both directions, the full length of the project. Did some slip lined some of the pipes, reconstructed multiple of the boxes. So it has significant drainage work with it. And the main reason for that was some of the water and some of the stripping that like I said, Jason I think will get into and talk about a little bit. We also had, as part of the scope, is to correct the super elevation. When the roadway was constructed, the super elevation was insufficient, and one of the things that we wanted to do was help correct that's elevation's deficiency, super elevation deficiency. Now we were able to do that, and it was one of the side products or side benefits of using CTAB. We were able to mill up the existing surface, blade out those tailings into where we increase the super elevation coming around the curves, and then lock them into place. We also did some bridge replacement. We replaced the bridge on the westbound side. We just finished that this year. It's the bridge that goes over the Union Pacific Rail Trail. It was a complete bridge replacement all the way. Now, like I talked about the challenges, some of the challenges we had, the project, to be able to complete it in concrete, we had to cross the traffic over. Now, anyone familiar with the area, and you'll see some slides that show it, is this is done in a canyon. It's Silver Creek Canyon. So the roadway for each section had mountains on one side and cut down into a ditch or a gully on the other side. So a very tight, confined area, putting all the traffic onto one side of the road, separated by a precast barrier, left very little room for any kind of shoulders or even any kind of emergency pullouts. So we had challenges in keeping I-80, which is the major east-west connector for trucking and roadway. We had to keep that moving, and had multiple plans in place to do that when we had breakdowns and accidents. So we had one lane in each direction. Difficult workspace, or difficult maintaining that traffic flow on that side. We had challenges with the super elevation that I've discussed a little bit already. They were deficient, and being able to work with those super elevations when you had cars on the other side also proved a little bit of a challenge. We also had the geography of the canyon. Like I mentioned, we were in Silver Creek Canyon. It was a divided highway, not only just horizontally, but also vertically. There are parts where the one part of the road is 50 to 100 feet above the other part of the roadway. We were also at elevation. Excuse me, we're up beyond Park City, so well up into the mountains, so we had a very shortened construction season. We had to get all this work accomplished, and we had to do it in short order and still working inside the confines of weather. Some of the others include, we had environmental sensitivity. There's a trail that goes down the middle. It's the historic Union Pacific Rail Trail. It has quite a few people that use that on a daily basis. So we had the desire from the local community to keep that open as well while we were working. Silver Creek also runs down in that area, so there were wetlands, and we had to protect the stream and be able to keep the debris as much as possible falling outside of that stream. Multiple stakeholder groups, Park City, Summit County, mountain user groups, the biking groups are up there, are a very strong, well-organized group. And most importantly, one of the bigger challenges we had was the accelerated schedule. Because of the failures that we were noticing, and the failures that Jason had been monitoring through some of these cores, we had concerns there may be significant or even a catastrophic failure in the pavement if we didn't get on it and get it repaired. So the project was supposed to have gone out a year later and been constructed a year later. So design was completed in, 5 months? We had design for this whole 7.5 mile with a bridge and significant drainage completed in 5 months. So working under all these constraints, we had this project that we had to produce. So significant challenges into being able to accomplish the goals we wanted to accomplish. Now, what I'm going to do is turn some time over to Jason, let him be able to talk about the design, how he chose and found out about CTAP, and then was able to incorporate it into the project. Jason.
Maybe that's short enough. So why cement treated base? The road through the canyon here was constructed in 1998, and it was about 8 inches of asphalt on cement treated base. So we had already put some cement treated base in this canyon. That was ours. This core does not even show the extent of what was bad. This wasn't from this job. This is another one. But when I would take cores of this roadway before we built it, essentially I had 1.5 inches of good stuff on top, and the asphalt was gravel to the point that when I cored it, it looked like a pile of rocks with no sign of oil. So now I've got a asphalt roadway that hadn't even made it 20 years. and was stripped and horrible. So now I have two options here, right? I can tear the asphalt off and I can put it back on that cement treated base, or I could do a concrete overlay. Well, I didn't like the asphalt option because it was essentially the same price as the concrete overlay, and I know that doesn't work because it didn't work in that location. So we had that major water problem. So now we decided the project's going to be a concrete overlay. UDOT has gone to putting their concrete overlays on asphalt for several reasons. It's not strong enough to reflect cracks up and various things, but so the traditional approach here would have been to just come in, put 3 inches of asphalt over the existing, 3 to whatever to fix that super elevation correction over on the side. But we got to thinking, well, if I do that, don't I just have the same problem? Won't my new asphalt just strip away and erode the strong base I'm trying to put that concrete on? So Lonnie and I were talking, kicking around ideas. Spencer Guthrie at BYU had done some research on cement treated bases. A lot of the interstate around here that was originally built in the 50s and 60s is on cement treated base, and so we know it works. We've built a lot of stuff on lean before it comes, and so out of that conversation we thought, well, that's a viable option, that might work. And I'm just crazy enough to say, why not? Let's go for it. It'll work. If you know me, you know I'll try something. There's no point in repeating mistakes. Let's just figure it out. So that's why I was trying to get a stable base underneath the concrete that wouldn't erode with the groundwater. Matt talked about putting in edge drains and drainage on the side, but this canyon has so much water flowing through there that you would actually see water coming up through our asphalt pavement, and it would not have rained for weeks and the road would be wet because of the groundwater coming up from the springs. So by putting that base as cement, then I've got a stable platform for my concrete that won't erode away in that water. I built an interesting section, if you think about it at the end of the day, because I have cement treated base on the bottom, old cement treated base that was hard and sound. Every time these guys dug down to it, that was solid. It wasn't going anywhere. And now I have this layer of stripped out old asphalt and then another cement treated base on top of that in my concrete. Which my take on stripped asphalt is as long as you don't touch it, it's at least as good as untreated base. And I've joked with a few people that maybe I just built a river underneath my road, right? The water will just run between the two cement treated base layers and not cause any damage to my concrete. At least that's the hope. We'll see what happens. Real quick, I'm not sure there's more than 1 or 2 people in this room that care, but when I ran the pavement design for it to try to figure out how thick my concrete needed to be, I ran it a couple of different ways. I ran it in Pavement ME, which is what we use for all pavement designs. It doesn't handle cement treated materials very well. Basically, all you do is put in a modulus value for that cement treated material, and you don't have to put in any other properties. A lean concrete base, you would use 2 million for that modulus value. I used 1 million when you're looking at cement ratios and all that stuff. It made sense to me. But because I have cement treated, stripped out asphalt cement treated, I'm not sure that software can really handle it. So I also did some back calculation of the whole pavement, hit it with FWD, took that as a composite K value, used the old AASHTO 93 design to get the thickness. Both of those procedures said I could probably have 11 inches of concrete. And so, being a conservative guy, I said, let's call it 12. Because when you don't know and you're not sure of the design procedure, you might as well add. So that got me there. So now we have the pavement design, the 12 inches of concrete on 4 inches of cement treated base, where the recycled, 100% recycled. So now how do I design this cement treated base? So I need a couple of things out of it, as I've talked. I need a stable platform. I picked 4 inches because that's kind of been the industry rule of thumb for leans and stuff like that, that's the minimum layer thickness. And that did truly turn out to be a minimum. Well, I think we recycled. Did we recycle 4 inches consistently? We consistently recycled 4 inches, but it was what I did is they came in and they milled it off, and then they moved those mill tailings around the job to correct for super elevation. And then they came through and added the cement powder consistently, which these guys will talk a little bit more. So that let me fix it, the super elevation correction, which was not an original thought as to why I did that. That just turned out to work out pretty well. But so I wanted a nice stable platform for my concrete. I want a material that is not so strong that it will reflect cracks. That's one of the reasons we went away from lean into HMA, because if I get a really strong base under that concrete and it cracks, that crack will come up through my PCCP. So now I'm in this area, right? I want something strong enough to be stable, but not so strong that it will reflect cracks. No one has really done it with 100% mill tailings, so we took some research from Spencer Guthrie, and it's shown that you want an unconfined compressive strength of about 300 to 500 psi at 7 days, which I'll talk about being the testing requirement. And it was really a shot. So it's just with cement treated base, the more cement you put in it, the stronger it'll be. So the real question is, how much cement do I put in? And that's the report we used from Spencer. It's from Spencer. He had targeted that if you're at 100% wrap, you would need up, 7. The 300 to 500 is the middle curve here. And so he was targeting you need almost 10% cement to try to get that strength. And Mincy winces in the background at that strength content, which is really the cement. We're getting close to the cement concrete of a lean base here, right? That's what you're building in place. So in our specs, we put out to do a test section in place at 7, 9, 11% cement. We did that test section. It ended up at 7. In hindsight, we probably could have been lower, 4 or 5% cement. So this is a case where all the research was saying way too much. In reality, we were able to use a lot less cement than what we thought, which was an added bonus. It saved me even more money. So then when we try to win an award, I can say, oh, look at all the money that I saved. From there. So that's how we got to there. So then the next step was to write a specification, right? So I'm taking the asphalt tailings, I'm adding cement powder to it in the field. How do I accept this material, right? How do I know that this is an acceptable material for what I have? So we thought we could do that in 2 ways. The acceptance section of the specification called for a rolling pattern. So basically just come in, add your cement powder, roll it, test that density, and just get it as dense as you can. Stop rolling when you can't get it any higher on your density curve. And then if we did that consistently, we knew we would have good compaction on it and we're probably okay. But that's a little vague, people want set concrete numbers for the acceptance, and so we also added in that unconfined compressive strength test, where you basically take a sample of the material, pound it out like a proctor, right, in your proctor molds on the site, and then cure it, and then 7 days later you break that like you would break a concrete cylinder. And that's where we were targeting 300 to 500. Almost everything was that or above, right? We only had 1 or 2 were low. If anything, when we were getting those test results back throughout the job, that's when we were seeing them above 500, and we were saying, well, maybe we don't need that much cement. And then the next piece is, now how do I, so that's the testing piece. Now how do I control this material to make sure I'm getting a consistent process? So really I left it up to the contractor and said, I just need a material that is 2-inch minus. Just don't leave me big pieces in there. And I didn't even put any acceptance testing on that 2-inch minus. Just told the field guys out in the crew here, hey, just every once in a while, take a 2-inch sieve, grab some of the material, run that over the 2-inch sieve, and make sure it all goes through there. And if you do that, then they're consistent. And I don't know how often they did that. Once every day. Type time frame. And then I also put on the materials the requirement of the prime coat to go on top of it. And I felt like that prime coat was extremely important because we talked about if I get too strong, the cracks will reflect up. So the prime coat worked double. It protected that material from raveling as construction traffic drove on it, and it gave me a bond breaker between that cement treated base and the new PCCP. So if I break that bond and they don't glue together, then the crack won't come back up. So in theory, that's how it was supposed to work. Hopefully it really worked that way. They ended up, I followed my standard prime coat spec. They ended up using an E-Prime, a different product, which is fine. It's a very similar material. So, what?
Got us an award.
Yeah. Got us an award. See, so you do whatever you can do to win an award. That's what we're all about. No, that's not true. All right. So now that's how I designed it. Maybe a few of you are interested in that. John's going to talk about what happened in the field, how they actually built it, and took my theories to reality.
All right, so I'll describe the process that Geneva Rock's the contractor on the project. Dexter's here with Geneva Rock, and the subcontractor also in part doing this is Coughlin, right? Is that Coughlin Construction? So they had the milling machine and the cement application. So also CMT did the quality control, and on our side, Terracon, Aaron Whitaker's here with Terracon. They did the unconfined compression strength on the material. So to start out with, the contractor profiled milled the existing HMA pavement. Once that was pulverized, then they applied the cement powder to the top. They had the apron on the side of this, on the end of the spreader to keep the dust down, and there are some requirements on this application. You know, they couldn't apply it if the wind was blowing too much. They couldn't leave the cement open up on top, and that was one of the requirements.
So real quick, Charlie, he talked about putting that on there to keep the dust down. I hope you can hear me. That's one issue with cement treated base in general, right? Is you want to put the cement down on top and then mix it in. And in a lot of environments, that dust is a real problem. Fortunately, we didn't have that problem here, right? We're up in the canyon in the middle of nowhere where I don't have a resident on the side of the road complaining about dust. But if you're going to select a cement treated base, you really have to think, is dust going to be a problem?
Okay, and once the cement was applied on top of the tailings, then they brought another rotomill and water truck to incorporate the cement into the HMA. This demonstrates this. It says density testing. This is more of a strength test on the material. So this, at the top, you see the extruded material from the Proctor mold. Then the material was saran wrapped to keep the moisture in, ziplocked in a baggie, and taken to the test, to the lab to do the test. So this was a 7-day test to get the results. As Jason had mentioned, the requirements were 300 to 500 psi. Once the cement was incorporated into the material, then they compacted with a sheep's foot roller, leveled the material with the grater, and then to finish off used a smooth drum roller. At this time, this is where we would take our density test and where we did the fill densities to confirm that they had adequately compacted the material. So that rolling pattern was done twice a day, once in the morning, once in the afternoon. And then viral prime to seal the existing surface, keep the moisture in, and then also to help with surface raveling, keep the top from raveling. All right, and you know, it's kind of one thing for engineers to try to put something together, but to get it built, you know, it really takes someone else, and that would be Kirby Woodard. So he was the main inspector on this material and did a phenomenal job documenting and working with the contractor to get the best quality product that we could. So Kirby gets the next portion.
So like John mentioned right there, I was on the inspection team part of this. There's some huge benefits to using CTAB, obviously. One of the major ones, I guess a couple of the major ones, time savings, where we was using the existing wrap that was already on site. That obviously saved us a bunch of exporting and importing of material, whether it's millings or bringing in lean base or HMA to put under your concrete or whatever Jason decides, and then in return to that, time's money. So just by using the recycled material, figure we probably saved this project at least $500,000, maybe even closer to $1 million. So I guess the benefits right there are huge. It makes sense. It's a great product when you're done. I think there's a lot of benefits to it. I don't know if these were necessarily factors when Jason decided what he wanted, but they're kind of benefits that come along with the product regardless. However, it's not perfect. There are a few issues, things to be concerned with. The first one right here is there's no shaping capabilities after 2 days. Realistically, within 4 or 5 hours, when you put the cement in and introduce the water, I mean, you're talking about a concrete kind of a product that you basically got a few hours to get this shaped to what you want. And then you're talking about the wet cure and things, but you don't want to, I mean, after that, you pretty much have what you built at that point. One of the other issues with that is when the cement's in with the mill tailings, there's a swell factor in there. We had some field guys out there that were excellent on the equipment. They understood that. They had to play with the idea of cutting it to a certain grade when it was made into the C-tab that accommodated for that swell factor, so that they had the final grade they wanted to go underneath the PCCP. So that's kind of down on number 5, where it's an art and a science. There's a lot of factors like that if you guys get dealing with this, you'll need to make sure you're aware of that. The water overlap soft spots. So there's not really a machine that does the whole process. So we're using a combination of a distributor truck, and then you got a mill. And the nature of a mill is to windrow the millings, put it on a conveyor belt and discharge it. So we just had the discharge belt shut down, but it's still windrowed the mill tailings. So each pass that the mill moved over, there was excessive water on those seams, and that's the water overlap soft spots, which if you used a different machine, maybe even a pulverizer of some sort, or if the industry felt we was going this way, they'd probably come up with something that worked a little better. But for the time being, we end up with some of these soft spots that are saturated down the road, which in turn result in rutting. It's kind of hard because the rutting, you got the excess water there, and then here we are calling them out to wet cure it until they get the E-prime on, which requires them to get on there with water trucks. So now you're putting ruts in your mat, and then when even the E-prime applicator truck comes through there, he can rut up your mat, which is obviously a problem like Jason hit on. Now your shear barrier, your bond barrier in between your PCCP and your C-tabs, probably not there because you got ruts in there, and it's pretty solid. So that could cause issues down the road. And then it's an art and a science. Well, let's see, I guess the weather right there. So like they talked about, the wind can blow the cement powder off, then that offsets your cement ratio, as well as maybe the public's involved at that point. You can get, we had a lot of rain the first year we did this. It was pretty forgiving on that, but the contractor had to be very aware of controlling the water they were introducing when they were milling it and mixing the C-tab to account for the rain that you was getting. Didn't necessarily shut us down. We didn't get to that point, but you could. But if you didn't have a contractor that was kind of paying attention, you probably want to keep a pretty close eye on that, because that is a huge factor. And then if you had excessive heat, this year it was a lot warmer and drier, and it definitely took a lot more effort and equipment to do the wet cure process, because Mother Nature wasn't doing it for us, and it was a lot of effort on their part to keep the wet cure process going until they applied the E-prime on there. And then, so it's an art and a science. You have to mitigate the weather, like I just talked about, and a lot of it's just the fact that there's not really a machine made to do the whole process in one pass. You end up with a different combination of things going on, like the mill and the distributor truck that I talked about. It's a forgiving process. There's a couple reasons, I guess, for that. Usually when you're talking about concrete or asphalt, you're dealing with your final mat on your road, but here we're mixing them together. But you got to still remember we're talking about the subgrade here, so there's some adjustments there, but maybe your expectation's not totally in the concrete rules or the HMA of what you're exactly looking for, because we are just still dealing with subgrade here. And then the weather conditions can be mitigated, so I mean you can work with it in a lot of different environments as far as that goes. And then considering all these variables, I mean, yeah, there's a few things that can change you keep an eye on, but like Jason mentioned, we didn't have hardly any problems at all with the compression strengths coming in. It was always there, if not on the high side, so we don't have any problems yet, I guess I should say. I know Jason's got some concerns at times, but for now we're calling it good, so it is definitely forgiving. And then the contractor's experience, it's very important. As mentioned, you end up with several different machines out there making the process. They got a whole lot of different elements. Each time you have a different machine in there working with it, they can change things greatly. They have to be very accurate when they're distributing the cement powder. These guys were out here basically measuring off 1,000-foot sections by hand, and then they had a scale on the truck, and they had the formula. I don't know how long it was, but he had a notepad in there. He was constantly calculating width and going off the scales in the truck, and that's key. I mean, you got to have a contractor that's dedicated to getting you a quality product, because if he's not, then there's definitely room for error out there. And then if you got rain, they got to mitigate for the weather, the wind, whether blowing your cement powder around. And then one thing Geneva was picked right up on was the swelling in the C-tab. That was huge. That they basically figured most of that out in the test sections right off the bat the first day, and I think that made the process through the entire project a lot smoother. And that goes into the teamwork's critical. Because it's an art, basically we all have to work together. There's some things in the spec that kind of make it hard on both of our ends. We're out there trying to get compaction, but at the same time we're holding them. I mean, they know they got a couple hours, 4 or 5 hours to get this thing mixed in, graded, and where it needs to be. So we're enforcing this compaction rule, but you still got to keep in mind they need some time to work with this and get it to where it's a quality product and going to work for us. You also got the wet cure process going in after you've graded it that if it gets too wet, then it puts you right back in the rutting issue. So you're constantly balancing that at the same time as you're going through the wet cure process. And then another issue we kind of found with it is where the sides aren't contained because you've milled the whole road. The edges can be tender. After the process is done, construction traffic's got to be, you got to be conscious of what you're doing. The contractor does. If he's putting a lot of construction traffic on the edge, it can unravel on you, and then you got to mitigate those issues. So that if you're not adjusting the profile, maybe there's sometimes you could if you didn't mill the edges and contain that, you probably get around that. But where we adjusted the profile, we had to be conscious of that. And then another thing we come across, you think of C-tab and you think of cement, but it's not a cure-all. It doesn't bridge soft spots. Don't probably, you need a good solid stable subgrade to put it on to get what you want out of it to start with. Don't think it's going to fix it for the next layer and so on and so forth, because it won't. We tried it and we ended up having to do some different things there. So that's pretty much how it went out in the field. I guess I'm glad Dexter's here from Geneva. Shane was on the project, and I'm glad that they were there with their experience, because they've dealt with lean base and things like that before, and they had definitely a lot of experience and pointers and things to watch out for. Very knowledgeable and familiar with the type of process we needed. They had a great direction, and they were able to make changes through the process, and I think they gave UDOT a pretty quality product there. And we all probably could have spent a lot more time figuring things out and maybe not got the quality we wanted if we would have had just a new contractor or somebody that's unfamiliar with it. So definitely appreciative of that fact that Geneva was there. So that's all I got, and if anybody has questions, these guys will answer them for you.
Let me give a quick conclusion. It's a process with promise. I mean, it has its application, and I think Jason and all of us understand the limitations of it. It has areas that can be used, and has some that probably would be more of a challenge, but it's a great process. We were able to do 7.5 miles of paving in 2 weeks. Was it 2 weeks? 3,500 feet a day with this process. I mean, it goes and it moves, and you can get in, you can hit it, and you can get it done. Provides a great base for you able to build on. And again, I want to also thank Geneva. They did a great job with it. They were right there with us, trying to help solve problems. They understood that this was something new the department was trying, and they did their best to help us make us successful. And I want to thank Geneva for the work that they did and pushing this. Other than that, I think, like I said, there were very few issues we had. We were able to resolve most of them quickly, and I think it has definitely applications in the future. So, with that, we kind of wrap up. Are there any questions you have for anybody on the panel? They did the concrete paving. Geneva was the prime contractor. They had Comers working underneath them that helped us with some of the CTAB application, but it was their direction. Honestly, I feel like that really drove the process and helped us succeed. Anybody else?
Let me ask one, Matt.
Sure.
I never asked you this question. Were there any issues with being short or overrunning your PCCP? Because once you set that base, you were set at that elevation when you had to come on the top of it?
The way I understood it is they were claiming, when I was talking to the paving division, why am I forgetting Brian? Talking with Brian one time in their paving division, he said that this provided such a stable, solid base that their yields were right in line with where they should be. I mean, they felt like they were hitting numbers right along there with what was expected. And Jim, maybe you could, if you know anything, I don't know if you were up on the details in that. Okay. Yeah, there. Yeah. Especially, the second year we did automated machine guidance, and it pulled the yields right down to where they should be, really tight. Well, even with the wire system, I think we had very few overruns. It provided a good, solid, finalized base. And we used the 3D to help guide the laying out of the CTAB as well. So between those two, it tied everything in tight. Any other questions? Okay, well, thank you for coming. If you make sure the roll's gotten around, you got your name on the roll. If you're from out of state, you need a hard copy, you can come up to the front. But other than that, thank you very much for coming.